Okay, so you're a recent computer science grad. You've put in the work, you've definitely mastered the code, but let's be honest, the job market right now is tough. You might be feeling a little bit of that anxiety. Well, in this explainer, we're going to break down exactly why that is, and more importantly, we're going to reveal the one key skill set that can change literally everything for you. All right, let's get into it. So let's kick things off with the heart of the problem, what I'm calling the graduate's dilemma. It's this super frustrating situation where you have all these highly qualified graduates who are really, really struggling to land that first critical tech job. And look, this isn't just a feeling people have. It is backed by some pretty stark data. A 2024 analysis from a university in Toronto showed that a staggering 43% of their computer science grads were still unemployed 6 months after graduation. 43%. This is not some small, isolated thing. It's a huge trend, and it points to a major, major disconnect. Which brings us to the million-dollar question, the one you've probably been asking yourself over and over again. You did everything right. You got the degree, you can write code in your sleep, so why in the world does it feel like you're just hitting a brick wall? Well, the answer lies in this massive and often totally unspoken gap between what you learn in school and what is actually expected of you at a real job. And here's the twist. It's not really about your coding ability. It's about a completely different way of thinking about problems. And oh man, this picture just nails it, doesn't it? School problems are neat. They're self-contained, like shoveling snow from a perfectly square driveway. But work problems? Whoa. They are chaotic, they're all tangled up with each other, and the stakes are incredibly high. You're not just solving a little puzzle anymore, you're trying to model a complex, living, breathing system. Let's really break that down. In school, you get these crystal clear instructions to solve a very well-defined problem. The whole focus is just proving you can code the algorithm correctly. But then you get to work and you're handed these vague user stories and business needs. Your goal isn't just to write code anymore. It's to translate the messy reality of a business into a logical, scalable software system. It's a whole different game. Now this is where it gets real. This is from an actual case study of a grad who failed an interview. He was asked to model a business process, a loan approval process. But he tackled it with that school mindset. He just focused on writing a script instead of designing a system. He completely missed the entire point of the exercise, and yeah, it cost him the job. So what is it that employers are actually looking for? It's this stuff right here. You're seeing terms like unified process, use case analysis, UML diagrams. These might seem a little abstract, but they all point to the exact same thing. Companies want developers who can think about the big picture. They need people who understand process, analysis, and design, not just somebody who knows how to write a function. But here is the really good news. Now that we've diagnosed the problem, we can talk about the solution. And it all comes down to what I like to call a developer's secret power, a methodology known as the unified process. So what is it, exactly? Well, to put it simply, the unified process is a roadmap. It's a proven, systematic way to take all those vague business needs and turn them into high-quality working software. It is the bridge that gets you across that school-to-work gap. I absolutely love this analogy. Think of all those messy business requirements and confusing user stories as just a big lump of dough, right? You can't really do much with it in that form. The unified process. That's the machine. You feed the dough in, you turn the crank by following the steps, and what comes out on the other side? Perfectly structured code and database schemas. And this right here, this gets to the absolute heart of it. School teaches you how to code. This process teaches you what to code and, even more importantly, why you're coding it. It elevates you from someone who just follows instructions to someone who can actually design and architect a solution. And you definitely do not want to be a post turtle. The saying goes, if you see a turtle sitting on top of a fence post, you know two things for sure. One, he didn't get there by himself, and two, he has no idea what to do next. That's a coder without a process. The unified process gives you the context and the plan, so you always know how you got there and exactly where you're going. Okay, so how does this thing actually work in practice? Let's break it down. Let's look at how this process takes you from simple words on a page to a complete software blueprint. The workflow is actually incredibly logical and straightforward. You start by gathering these informal user stories. Then you formalize them into use cases. Next up is the magic step, lexical analysis. And finally, you visualize the whole system with UML diagrams, all before a single line of code is even written. Now, this step, lexical analysis, this is the real core of the transformation. It's a technique where you systematically deconstruct the language of the business requirements. I mean, you literally go through the text, you find the key nouns, you find the key verbs, and they become the direct building blocks of your software. The nouns, they become your classes. The verbs, they become your methods. It's that direct. Okay, let's look at a real-world example. This is a typical use case you might get from a business analyst. It's just plain English, right? It's just describing a simple action in a library. But hidden inside these simple sentences is the entire structure of our program. And boom, here's the result. By performing that lexical analysis on that simple paragraph, we can generate this, a UML diagram. This is the architectural blueprint for our software. It shows all the classes, you see them, user, book, librarian, and it shows exactly how they all talk to each other. This, my friends, is the secret sauce. But wait, how do you know where to put everything? How do you organize it? Well, you follow the knowledge principle. It's a simple, really elegant rule. You assign responsibility for any piece of data or any action to the object that knows the most about it. So, for example, who should calculate a late fee? Well, the loan object, of course. It knows the due date and it knows the return date. It makes no sense for the member or the book to do it. So let's bring this all together. Learning this process, it's not just some academic exercise. This is the key. It is the key to unlocking your career and setting yourself worlds apart from the thousands of other graduates who are out there competing for the same jobs. Why? Because when you master this, these are the kinds of tough, real-world interview questions you'll be able to answer with total and complete confidence. See, these questions aren't about obscure algorithms you memorized. They're about proving you can think like a professional software engineer and actually build real systems. And that really is the bottom line. It's what separates the coders from the professionals. Employers aren't just looking to hire a pair of hands to type on a keyboard. They're hiring a brain that can solve business problems using technology. So the final question you really need to ask yourself is this. Do you want to be someone who just writes code? Or do you want to be someone who designs and builds real effective solutions? The choice and the opportunity is all yours.